Module 2, Lesson 16, Even and Odd Numbers. This is a fun exploratory lesson, so there won't be a ton in the video. Of course, I think that, and then I'll probably do a whole lot. You will definitely want to pause and complete the activities as we go through so that you get the full learning experience. All right, I can statements. I can explain what makes a number odd or even. I can determine if a sum or product will be odd or even. Students will tell me that an even number is divisible by 2, and I will ask what that means, and they'll tell me that the number is even. So we'll explore what actually makes things odds and even, and we'll use models to represent so that we can see what's happening. All right, the opening exercises, this would be a time to pause and go through each of these questions, recording your thoughts, thinking through this deeply. What is an even number? List some examples of even numbers. What is an odd number? List some examples of odd numbers. And once you've done that, go ahead and move on to exercise 1. And we're going to explore the question of why is the sum of two even numbers even? Why, when I take 2 plus 4, do I get 6? Why do even number plus even number equal even number? And to answer this question, we have to explore what are even numbers. And so we're going to use a model to look at an actual problem here and explore what's going on. So think of the problem, 12 plus 14. Draw dots to represent each of the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we've got 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Cool. I've got dots here. Now the next thing we'll want to do as we explore this is we're going to make pairs of dots because we are trying to figure out if there are any dots left over. So pairs are groups of 2. Here's a group of 2, and 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 here's a group of 2. And I've got a group of 2, and 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 a group of 2. I've got lots of groups of 2. There aren't any leftovers. When I was done drawing all of my pairs of dots, I had no leftovers. So what makes a number even? A number is even when we can make pairs of 2 out of the number and have no leftovers. So if I have 12 and it has no leftovers, and I have 14 and it has no leftovers, if I combine these two numbers, will there be any leftovers? And the answer is no, because all the 12 here have a buddy and all the 14 here have a buddy. If I put these numbers together, all the numbers will have a buddy and there will be no leftovers. What makes a number even? A number is even when I can make pairs of 2 and not have any leftover dots. Now the question is, will this be true every time I add 2 even numbers together? Did we just get lucky with 12 and 14 that it just happened to work out that way? What if I randomly pick 2 other even numbers and add them together? Will they also add up and be even and have no leftovers? This would be a time to pause, think that question through, and think about how you would explain that. Not with giving examples, but actually looking at the model here and seeing what is happening and explaining what happens with even numbers. And the answer is, this is true every time. Every time we add 2 even numbers together, we will get another even number because we'll never have leftovers. We'll never have dots left over when we are making pairs. Therefore, the answer will always be even. taking a look at exercise 2. Why is the sum of two odd numbers even? So numbers that aren't even are odd, which means we need to think about what does that look like. So we're going to look at 11 plus 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So as we look at what makes a number odd, I said numbers that are not even are odd, but let's explore for a moment what that means. If a number is even, I can make pairs of 2 and have no leftovers. So I've used my 11 here. I've gone and made pairs of 2, but I have a leftover dot. So this number is odd. With the 15, I have done the same thing. I have made pairs of 2. And once again, I have a leftover dot. Now we are trying to explore the answer to the question, why when I add these two odd numbers together, 11 and 15, do I end up with an even number? Why do I get an even number instead of an odd number? Well, the answer is in the models. When I have 11 and when I have 15, and when I combine them, my two leftover dots can be paired off with each other to make one more group of 2. So with the 11 plus 15, it's kind of like I'm adding the 10 and a 14, because the 11 is 10 plus 1, and the 15 is 14 plus 1. So here's an even, and then I'm going to take their odd parts, their little leftover dots, and I will put them together and make yet another pair. So what I really have here is 14 plus 2. Not 14 plus 2, 25. Oh, 24. Boy, it's Friday as I record this. 24. So there's the 10 and the 14. And there's my two oddballs. So altogether I will get 26. So as I look at the model here, I can see that inside of these odd numbers, I have the even number 10, and I have my leftover. I have the even number 14, and I have the leftover. And when I add the 11 and 15 together, I can combine these leftovers to make one more pair. So circle of pairs of dots, yes, we had leftover dots, but then I can combine them, which I've said like 3 times now. Now, is this true every time that two odd numbers are added together? Why or why not? So think about this. If you were to draw models of any odd numbers, what would you always have left over if you made pairs? Well, you would always have a dot left over. And if you combined that with another odd number that has a dot left over, then those two leftover dots would always be making a pair. So yes, this is true every time. Every odd number will have one dot remaining after we make pairs. And since each number has one dot remaining, these dots can be combined to make another pair. Therefore, I have no dots left over, and I get an even sum. All right, looking at exercise 3. Why is the sum of an even number and an odd number odd? So if I take 3, which is an odd number, and I add it to 2, why do I get an odd number? And of course, we should extend that and ask, does that happen every time? Hopefully you're starting to see a pattern emerge in this lesson. Well, let's think of 14 plus 11. And let's go through with our model here and see what's actually happening. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's my 14. And then I've got 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's my 11. And I'm trying to combine all of this. 14 plus 11, I'll have 25 dots, which is an odd number. And the question is, why is it odd? Well, let's take a look at what's happening with our pairs in here. Here's a pair, 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 here's a pair. The 14 is all pairs, no leftovers. Let's take a look at the 11. Pair, 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 pair. So I've used up 10 of the 11, but I did have one piece left over, one dot that didn't have a buddy. So when I combine all this together, the 14 and the 10 will combine together to make 24, but then I have my oddball dot all by himself. So as we look at the model and we start to extend this in thinking about all situations of even numbers and odd numbers, the even number will always make pairs. There will be no leftover dots with the even number. With the odd number, there will always be a leftover dot. So if I combine the numbers, I will always have this one dot left over, so I will always get an odd number. And it'll say to make the dots here, and we've done that. So is this true every time an even and an odd number are added together? Why or why not? Well, it's always true when an even number and odd number are added together, because only the odd number will have a dot remaining. We won't have a buddy for it. We won't have a pair. And since this dot does not have a pair, the sum will be odd. Now here's an interesting question to think about. What if we change the order of the add-ins? What if we did 11 plus 14 instead of 14 plus 11? Would that change anything? And if you want to go ahead and pause the video and make your model and think about that, go right ahead. Would I still get an odd sum? Well, the sum is still going to be odd, and there's two reasons here. First, we have the commutative property. And the commutative property states that changing the order of the add-ins does not change the answer. 11 plus 14 is the same as 14 plus 11. But if we look a layer deeper, and I like this sentence here, this is the more important to me. The odd number is still odd. There will still be a leftover dot. Just because I have changed the order of the add-ins does not mean that the nature of the numbers has changed. The 11 here will have 5 pairs of 2 with a leftover dot. The 14 is going to have 7 pairs of 2. There is still a leftover dot. So the commutative property is a nice explanation, but I think deeper, more conceptually, thinking about what makes numbers, odds and evens. All right, so kind of thinking back through these first three exercises, and we're going to just make some general statements, and we've already seen these, but just a recap here. If I add two even numbers together, the sum is even. If I add two odd numbers together, the sum is even. And if I add together an even number and an odd number, the sum is odd. So these are general statements that can be applied throughout math. Add two evens together, you're going to get an even. Now what this means is as you're working on math problems, if you're adding two numbers together, and you look and say, hey, I've got an even number, hey, I've got an odd number, I should be able to say my answer is odd. I've now got another layer of number sense that I can use to check my work. If I can remember these generalizations, I can use them as part of my number sense. All right, so we've looked at addition. Let's take a look and see what happens with multiplication. And you want to go through the same process that you went through with the addition problems. So think about how we tested statements in exercises 1 through 3. We drew models, we made pairs, we saw what was happening. So here is a statement: the product of two even numbers is even. And you should pause. You should make a model of two even numbers being multiplied. And you should examine the model and determine if this statement is true and why it is true. So for example, if I were to use the problem 4 times 2, and I could interpret this as 4 groups of 2. So I've got group of 2, group of 2, group of 2, group of 2. I've got 4 groups of 2. So I've got my dot model. And I know that 4 times 2 is 8, so an even number multiplied by an even number gave me an even number. I can now look at the model and try to figure out, why is this statement true? Well, I've got my 4 here, my even number. I've got my 2 here, my even number. And now I'm going to look at the product and I'm going to make groups of 2. Group of 2, group of 2, group of 2, group of 2. So looking at my model here, when I'm multiplying even numbers by even numbers, I will always be able to make pairs of 2. I won't have any leftovers. For example, what if instead of 4 times 2, I was to look at 6 times 4, which would give me 24. So I've got my 6, 1, 2, 3, 4, 5, 6. And then I need my 4. And I start making my groups of 2. I start to notice as I come down this way, if this is 2, if it's 4, if it's 6, I'll be able to make these pairs vertically. I'll always be able to pair off these 2. The next even number would be 8 or 10. I would always be building my array in sets of 2. Well, what if I were to look at it the other way? What if instead of going vertically, I were to try and go horizontally? What if instead of making my pairs going up and down, I made my pairs going this way? Well, once again, I've got groups of 2. So my even number by my even number gives me even numbers. No matter which way I look at my model, I'll get even numbers. So I think I can say that the product of 2 even numbers is even because when I draw my arrays, when I set up my model, I can make groups of 2 and I don't have leftover parts. So what about this statement? The product of 2 odd numbers is odd. So for example, what if I were to do 5 times 3? 5 is an odd number, 3 is an odd number. I know the product is 15. And if I set this up as an array, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So here's my 5. Here's my 3. Now as I start to look at this, if I take my 5s and try to make pairs, I'll always have a leftover. And I can combine 2 of the leftovers, but I'm going to have this one dot all by itself. I could try and go the other direction. What if I take the 3 and try to make pairs? I still have that leftover dot as I go and put things into my array. I could try a different odd number. What about 5 times 7? Well, I just used 5. What about 7 times 9? That's a little big, I think, for the model, but I'll go through it here real fast. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. And we sit here and we go through and we take our process of making pairs. And my dots are kind of all over the place. I didn't do as good a job building my array here. So I'm going to get kind of all over the place here. There is still that leftover dot hanging out in the corner, because the 7 is made of 3 groups of 2 and 1 left over. And the 9 is made of 4 groups of 2. And there is the 1 left over. And when we intersect those, unlike when we do addition, because we're multiplying them together, we're not going to add these 2 ones together. It just means there is 1 left over. 3 times 2 is the 6 and the 8, and I've just got the 1 left over. And I'm pretty sure that's a really crummy explanation, but the model shows it better. There's always that little leftover dot down in the corner. All right, so exploring, the product of an even number and an odd number is even. So if I take 3 times 4, I get 12. So I've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh, 3 times 4. So here's my 3. There's my 4. And I can make my pairs. Now, because vertically I have 4, I can see that I'll have my sets of 2 here. And because I am running vertically, I can see that each of my 3 will have 2 sets of 2. If I run it the other direction, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. If I make my pairs go the other way, I've got 2, 2, 2, and 2. So I've got 4 pairs of 2, and then I've got 2 more pairs of 2. My odd sections, my 4 odd 3s, will combine together to make 2 pairs. So thinking of this in general terms, the product of 2 even numbers is even. The product of 2 odd numbers is odd. And the product of an even number and an odd number is even. Now, as we think about how does this help with division, because that's what we've been studying, well, when we divide, it can help us to know whether the sum or product of 2 numbers is even or odd, because it narrows down possible factors. If a dividend is odd, for example, 35, then I know that the factors must be odd because the product of two odd numbers is odd. If I have a number, 231, I have to know then that the factors must also be odd because the product of two numbers, odd numbers, is odd. So I can extend these and use these. They can be helpful as I think about them. So the two numbers that I can multiply together to get 231 must be odd numbers. If I have an even number, then there's two possibilities. I could have even times even, or I could have even times odd. But in both cases, at least one of the factors will be even. So I have now just another layer of number sense that I can use to help me evaluate my answers and ask whether or not they make sense. So here are our summary statements, the generalizations that we've made. Once again, very useful number sense, things that if we can embed into our line of thinking, they can be useful and powerful for us. So hopefully, after this lesson, you can explain what makes a number odd or even, whether or not you can make pairs of two and not have any leftovers, or you make pairs of two and you do have a leftover. And hopefully you can make some predictions whether or not sums or products will be even. And more importantly, you can extend that, and as you are working on division, ask yourself, what do I know about the factors of this number? So that concludes Module 2, Lesson 16, just an exploration of odd numbers, even numbers, and some of the generalizations. If you've got questions, make sure you talk to your teacher. Once again, this is a great lesson for exploratory, going hands-on and actually working with things and seeing what numbers look like. And make sure you complete your problem set.